Hello, everyone, and welcome to Measuring Moisture Content in Food and Supplements. Today's presentation will be about 30 minutes, followed by about 10 minutes of Q&A with Dr. Zachary Cartwright and Connor Jeffries, food scientist and food lab researcher, respectively, here at Meter Group. If you do have a question for the presenters, type it into the questions pane at any time during the webinar, and we'll be keeping track of these to answer during the Q&A session at the end. So please don't be shy and submit those questions. And we'll also be sending out a link to the on-demand webinar as well as the slides and transcript for you to review as soon as they're available. So without further ado, I'll hand the microphone to Zachary to get us started.
Thanks, Brad, and welcome everyone. Thank you for being here for a Meter Food webinar. Today, Connor and I will be talking about measuring moisture content in food and supplements. I know Brad already introduced us, but here's our information. Again, my name is Zachary Cartwright. I'm a food scientist here at Meter. I also work as an educator and host the Water and Food podcast. And I'm joined by my friend and colleague, Connor Jeffries.
Hello and good morning.
The way that this is going to work today is we're going to be covering some research that Connor has recently worked on and collected some data. So we're going to kind of work this through an interview format where I'll be asking Connor kind of a series of questions before we talk about a new technology that Meter has released. So the first thing that we'll talk about is simply what is moisture content and who is measuring it and what makes measuring moisture content so difficult. From there, we'll be talking about methods. I think we have this listed as direct and indirect methods, but we'll be talking about it more along the lines as primary or reference methods versus other methods. From there, we'll look at some of Connor's research that he's been working on. Then we'll talk about some of the things that you and your team can be doing to reduce variation and improve your accuracy. From there, I'll be talking about a brand new instrument called the ROS1 that can be used to quickly measure moisture content. And again, we'll look back at some research and see how this new instrument compares. And then at the end, we'll just be simply talking about choosing the right instrument for you and your team. So to start off, why moisture content measurements can be so fickle. And the first thing I want to do is simply start with a definition of what moisture content is. So Connor, how would you explain moisture content to somebody?
Yeah, so I think it's important to start from the beginning here. So what is moisture content? It's really, we're just talking about the mass of water compared to the mass of everything else in your substance. So I think it can be a little bit confusing because it's necessarily, you have to get the water out to measure it. So there's no real way to measure it sort of in situ. So you have to remove the water, and that's really the tricky part. So typically what we do is we'll heat up the sample and we'll remove the water that way. So that's called loss on drying. The other option is to sort of dissolve your sample along with the water into a solvent, but that's pretty specific to certain methods.
And who is measuring moisture content, or maybe who should be? Why is this important, and who is looking at this?
Right. So moisture content really is about, percentage. It's about yield. It's about mass. And so I think most people want to know how much moisture is in their sample, but really moisture content specifically should be about knowing yield. I don't think it's a great measurement for quality control or quick checks.
And then as you measure moisture content, what are some of the difficulties that you may come across?
Right, so because it's so dependent on the process, we have to remove the water, and we have to typically put energy into the sample. So that can run into problems where you're removing, so the assumption is that you're putting in heat or energy and you're removing the water. So if you remove other things, other volatile compounds, that will overestimate the amount of water. Also, if you're putting in so much heat that you start decomposing your sample, you'll lose stuff in the form of gas, and you'll overestimate the amount of moisture from that as well.
So how do you know how long to heat something or what temperature to set it at?
There's a lot of reference methods, so you really have to do a bit of research to get to the bottom of the best methods for your particular samples. But typically low and slow is kind of unfortunately the best way to go. It's the safest, which is the most accurate.
And anything else about samples? You mentioned volatiles earlier, but what might make a sample easy to measure moisture content, and what are some of the more difficult samples that you've come across?
Um, Things that are difficult, I'm going to say cannabis right off the bat because I've been doing a lot of work in cannabis recently, but also dried fruits, particularly tricky, dense things, things that have lots of sugar in them,
Mhm.
things that are hard to sample. So sampling plays a big role in being able to get the moisture out. So those are kind of the things that I would consider difficult samples. Easy samples are things that are typically high in moisture content that can easily evaporate. Um,
And then the last point you had in here is, do you really need to measure moisture content? And I think this goes back to your original point. Moisture content is more for yield, but is there another measurement, or how else would you look at the water?
Right. So for yield moisture content, there's really no other way to, know the mass of water in your sample. But if you want to know how the water is in your sample, water activity is a much better measurement. Because water activity is basically, it combines the moisture content with sort of the structure of your sample. So it's kind of it doesn't tell you like the percentage of mass of water in your sample, but it tells you how that water is available in your sample.
So if you're concerned with yield, maybe use moisture content, but then
Right.
safety and quality, that's when you want to start bringing in some water activity
Right. Water
measurements.
activity is much better for that.
All right, from here, let's look at some of the methods that are used to measure moisture content. There are lots of different methods, but we're going to kind of focus on these top three. So the first one we have here are ovens or vacuum ovens. So what is this method? How does this work?
Right. So this is kind of the tried and true original, method. If we go back and look at sort of AOAC, we can see lots of oven methods from the 20s and 30s. And so, I mean, those haven't changed in hundreds of years. You put a sample into a really stable heat source, it heats it up. You know how much heat you put into it, and you basically just check the mass to see if it's stopped changing. Um, so they're they're very reliable. Most labs have an oven, and yeah, it's staple.
The next one we have here, I know it's one that you like, Karl Fischer titration. Well, why do you like this method, and maybe why do others dislike
You're
this
right.
method?
Yeah, I mean, I like Karl Fischer because I'm a chemist. So my background is chemistry, and it's kind of fun sometimes.
Mhm,
That being said, I see lots of people using Karl Fischer titrators in sort of the wrong way. Like,
mhm.
I think they're drawn to the fact that it can be really precise and accurate, but there's a whole pipeline of chemistry that's involved in using it. I mean, they were developed for measuring small amounts of water in like fuels and other, petroleum products. So it's really good. It's basically, it doesn't matter what else is in your sample because it's chemically selective for water. So that's kind of nice
And,
for.
and this is when you really want to pinpoint to like parts per million, is
Yeah,
that correct?
I mean, it's not great for. It's actually really not great for lots of water. So
Mhm,
high moisture content samples, like you have to really make your samples really small if they have lots of water in them.
mhm.
So it's best for small amounts of water.
And then the third one we have in here are moisture balances. I see these a lot, especially within the food industry. What's a moisture balance, and how's it compared to these other two?
Right. I think moisture balances, in theory, were kind of developed to sort of marry. So with an oven, you have to make the mass measurements yourself. You have to have an analytical balance. And so the idea for a moisture balance is that you're combining a heat source with a balance. So that's at least the idea. In practice, my experience with them has been less than ideal, but they can be very fast.
And we'll look at some of the data later in this presentation and to see why they're not really ideal. Out of these three methods here, which of these are reference methods that you see being used in the cannabis industry or food or pharma industries?
I mean, oven's always going to be a reference method, and I think lots of pharmaceutical labs perhaps use Karl Fischer. I think I've seen it in some cannabis labs. I know I've used Karl Fischer for testing cannabis,
Mhm.
but I don't think moisture balances are particularly known as reference methods.
Sure. Well, from here, let's look at these just a little bit more and look at some of the pros and cons of each. So let's start with the oven here at the upper left. What are some of the pros about working with the oven? What do you like about this method?
Right. Again, very stable. You can put lots of samples in it, so you can do large batches. The problem, I mean, the main problem is that they're not super fast, right? You have to heat them up, but that's kind of like they're pro as well, right? They're stable. So, and then of course, you know, lots of people have ovens, so maybe you can just get a quick moisture content that way. And then I guess it's con if you don't have an analytical balance, buying an oven and an analytical balance can be expensive. So
And then Karl Fischer, what are some of the pros here as well as the cons?
again, very precise. It's compatible with, well, things that are volatile, but at the same time, it requires that the samples be soluble basically in organic solvents. There's other ways, there's some ways around that, but it's always going to require this like chemical pipeline. So if you don't have, you know, a good chemistry handling area or whatever, it's going to be a problem.
So maybe not the best device for a startup or a new company.
Yeah, they tend to be quite expensive. And if you don't have a chemist to run it, it can be a little bit daunting, I think.
And then last one here, moisture balances, some of the pros and cons for these devices.
Right, so moisture balances are fast. They combine the drying and the weighing. But in my experience, there's a whole range of moisture balances. There's cheap ones. There's, you know, you can pay, you know, I don't know, several $1,000s for a moisture balance, which sounds like maybe a good deal because, you know, balances can be expensive, ovens can be expensive, but you know, I've found that the performance of them varies widely. The other thing is that they're not actually, you don't actually know the temperature of your sample. So it's just doing its best to estimate your sample temperature. And because of that, it can, you know, decompose, at least in my experience, it can put too much heat into your samples.
And we'll look at an example of that as well.
Right.
There's a couple other methods that we just wanted to mention. These three methods so far, these are not the only methods, but there are a couple others that Connor has looked at. So we're just going to discuss them briefly. The first one is this microwave method. What is this and how does this work?
Yeah, it works very similar to a moisture balance. The idea is that instead of using sort of a halogen bulb or an IR heat source, it's using a microwave source. Works great for wet samples, samples that have lots of water in them. My experience with them is pretty similar to moisture balances where they, for dry samples, they just tend to decompose things and cause issues.
And then the next one we have here is distillation.
Right, this is a little esoteric as a chemist. I'm like, yeah, just do a distillation. But you know, this is a reference method. So the AOAC is like, hey, if you need to distill your sample or do a distillation with your sample, it can work. So for something that has like lots of volatiles in it or other conflicting compounds, I might go back to distillation.
And then the last one we have here are just using desiccant chambers, kind of the same thing, right?
Right, yeah, so the idea here is that you have just a drying chamber, you're not introducing any heat, and there's either a desiccant or something like molecular sieves just trapping the heat, or sorry, just trapping the water in them, and it's just equilibrating into a really dry chamber. So that takes a long time, right?
Yeah.
Maybe a week or two. So it's not, maybe it's a good reference, but it's not going to be something you do regularly.
Sure. All right, from here, let's look at some of the research that you've completed. So we're going to look at a variety of different products. Here we're looking at dried mango. And I just want to point out that a lot of these graphs are looking at the difference from the reference oven method. And maybe you can describe why you set these graphs up that way, as well as what we're looking at here with different moisture balances. Are these the same balance? Are these replicates? Are these different instruments? So maybe you can just break down this graph.
Right. So for most of this data that we're going to look at, it's a moisture content difference from a reference oven method that I found for these particular samples. And these are 3 different moisture balances that I tested. And then in this slide, there's also a moisture analyzer. And you can see that the moisture balances are struggling with a dense sort of fruit sample like dried mango here. They're not able to fully remove all the water in that sample. Conversely, you see something like the microwave analyzer that it removes all the water, but then because it's dry and it's got a lot of sugars in it, it starts burning it. And so you overestimate. Um, and if we go to the next slide, so this is you're overestimating by 4% moisture content, but in reality, that's almost, that's like over 40% off from your sample. Right? So it's a large margin.
Mm-hmm. And do you see this often where those samples are getting burnt? Why does that happen in some of these instruments?
It's just too much energy being put into them. And, it's not, again, like a microwave and a halogen bulb, they're not at a set temperature, right? So you're just pumping a bunch of energy into your sample, which again, works great for wet samples and things that you want to dry quickly. But as soon as that initial sort of moisture is out, it leaves your samples really susceptible to burning.
And is the same true? I know we have another dried fruit sample here, so dried blueberries. The results here look really similar. The moisture balances are having the same issues, right?
Right. Yeah. So the moisture balances don't burn these particular samples. And I didn't get a microwave moisture content for these because they burned them. So I stopped. But so the moisture balances, again, underestimate. They're not able to get all that moisture out from these dense samples.
And then let's look at some other types of products. So here we have a protein and greens powder. What's happening with this type of product?
Right. And this is a particularly dry, we're talking less than 5% moisture content sample. And they're unable to, they overestimate because they start decomposing, right? So like we saw with the dried mango, these particular very dry powdery samples are easily burned by all this IR power getting pumped into them.
And the same is true for this whey protein powder as well. So it looks like, again, the same thing is happening.
Yeah, and it's just overestimating because it's decomposing the sample.
And then I believe we have one more in here for cannabis. This one is set up a little bit differently. So this is just the total moisture content using several different methods. Can you walk through this graph?
Yeah, so there's no sort of consensus best method for moisture content in cannabis, and I'm doing a lot of research right now trying to kind of get to the bottom of it. But we can see that some, sort of reference methods, Karl Fischer, Duskin Chamber, those match pretty well. But once you start getting into other methods where you're putting a lot of heat in, we know that cannabis has lots of volatile compounds in it. So we would expect that putting lots of heat into a sample, perhaps in a vacuum oven, would it would overestimate the amount of moisture. And we kind of see that in a vacuum oven method or in moisture balance at a higher temperature, or using an oven. This American Herbal Pharmacopoeia method is an oven at 105 degrees. So.
And I actually just released just a short article explaining the need to kind of standardize the moisture content method being used in the cannabis industry, because if you're producing cannabis, you might send your product to a certain lab because you're getting numbers that you like, because they're using a specific type of method where it might make your product look different than it really is, or different than if you send it to another lab.
Right, yeah, and I think all THC content is pinned to dry weight. So these numbers affect your potency calculations. And I think the California Cannabis Control Board has realized that this is a problem and they need to get to the bottom of it.
From here, let's talk about a few methods that you could be doing, or if you're listening, some things that your team could be doing to reduce variation and improve your accuracy. So what could teams be doing differently, Connor?
Right. I guess the first thing I would say is, do you really need moisture content? Do you really need these yield numbers? So if you're just doing quick checks, water activity might be a better metric for you.
The second thing you have in here is method validation and proficiency testing. What do you mean by this?
Right. So, are you testing with standards, your moisture balances? Are you testing an oven? Are you checking that your methods are actually valid? So I think that's something that I spend a lot of time doing. We verify all of our instruments, constantly. So.
But I'm always surprised when I speak to people in the industry, how many people actually aren't taking this step, or they're not doing it very often.
Right. Yeah.
The next point we have in here is many replicates. Of course, for anything, the more replicates you have, the better. I mean, how many is enough, or is more always better?
Yeah, it kind of depends. Like I guess I would say more is better,
Mhm.
but to a degree, right?
Sure.
You can do the statistical analysis if you want.
Mhm.
But this kind of ties into method validation and proficiency testing, is that you need to basically reliably say that this is the moisture content of your sample, and you
Mhm.
do that by taking many subsamples.
The next one we have in here is just standardize your method and look to the regulators. So, whether it's AOAC or these other ones that we have listed, making sure you look and that you're using the right method for your product.
Right, right. So yeah.
And then the last one we have here is using a moisture model from an isotherm. I decided to put this one in here. This is something that we do a lot at Meter, basically taking your moisture content based on a water activity measurement and the relationship between these two measurements, which is called a moisture sorption isotherm. So we can make a model this way and then get a really high precision moisture content measurement.
Right. Yeah, we do this a lot. We know the moisture content relationship with water activity, and you can get moisture content from water activity, but you can't get it the other way around.
Yeah, that's true. Okay, so from here, let's talk about a brand new instrument that we've released here at Meter, something that's going to help your team measure moisture content very quickly and precisely. So this instrument is called the ROS1. I took this from our marketing. They have not hotter, just smarter. And I like this because, like we've discussed for some of these other instruments, they've tried to get quicker measurements by heating up samples very quickly. Those moisture balances are using halogen bulbs. And this just leads to problems. Like Connor showed, this can lead to samples burning or underestimating or overestimating the moisture content in those samples. So I just want to take a moment here, talk about some of the features of this new instrument, and then we'll look back at the data that Connor has collected and compare this instrument to what we've already looked at. So the first thing is that this instrument conforms with AOAC, ASTM, and ISO. So if you need to put in a specific time and temperature, you can do so with the ROS1. Here, there's no method development. So this is a sample agnostic instrument. You can put any sample in here and it will be able to measure the moisture content. The next thing I have is that it automates busy work. So you don't have to write anything down. It's going to automatically graph the time, the temperature, and the weight change for your product. It's rapid testing and high throughput. So you can kind of tell from this image, but you can put in 9 samples at a time. And within 40 minutes, you'll have the results for these 9 samples. So about 4 minutes per sample. It's really simple to use. This has to do with the desktop app that comes with the ROS1. It's called Bridge. It makes it really easy to start a test, to view the data that you've collected, and then export out that data as needed. Here, the results are going to be really precise. This has to do with the temperature control in this unit, as well as the vapor pressure control and the scale that is in the ROS1. Here, the results are highly repeatable. It has to do with having a lot of control over those previous things that I just mentioned. And something really cool about this instrument is the auto dry detection. So as evaporation starts to slow down for the sample, the instrument can actually detect that, and it will start to take more measurements so that it can stop the test right when that sample is dry. I thought I would also have you talk about, Connor, how this helped to improve your workflow for using it in the lab.
Yeah, for sure. And I think one thing that stands out to me is not having to use weird little buttons on a tiny little instrument.
Mhm.
I think for a while there, that was sort of the way to build instruments, was to make everything standalone. But I
Sure.
think moving back to having a desktop really streamlines the data side of things, at least for me.
Mhm.
And also the instrument itself is just, it's a breeze to use. So.
Mhm. Now let's look at some of the things that you collected. So looking back at dried mango, now ROS1 is there on the far right of your screen. What is this showing us?
Right. We're seeing that the ROS1 is really able to get really close to the reference method for dried fruit, whereas these moisture balances struggle to get all the moisture out because the ROS1 is basically a reference method. It's very consistent with the oven.
And then let's look at, again, the dried blueberries. Same thing
Very
here, right?
similar, yeah.
So really close to that reference oven method. Let's look at the protein and greens powder. Again, really close.
Yeah, I feel like we're picking on moisture balances. It's because they really struggle like with a lot of samples. So, I mean, it's fair to say that they don't work very well with these samples.
Here we are again. This is showing it a slightly different way. Can you explain
Right,
why you're
so
showing it this way as well?
the previous slides were a just actual moisture content difference. This is that moisture content difference as a percent difference from the reference. So because those moisture contents are small for this particular sample, we can see that a small change really results in a large percent difference. So even though the moisture balance might have had somewhere around 1% difference absolute, it's about a 15% like moisture content difference from the actual reference method. And I just want to point out we're basically shooting for about 2% precision here. So this difference of about 2% is kind of the uncertainty of both the reference method and the ROS one.
And then next we have the protein powder.
Again, yeah, the same thing. This is the absolute difference, 0.1%. The moisture balances are overestimating considerably compared to if we look at the percent difference here, about 2% for the ROS one, and upwards of 4 to 15% for the moisture balances.
And that 2% for the ROS one is again kind of within that expected range that was the target.
Right. Yeah. So I think it's not this slide, but there's one slide after this. We'll look at precision. But
sure. I like this slide a lot. So here we're looking at a moisture standard. Is that correct? And why is this slide important?
Right. So this is looking at sodium tartrate, which is a pretty common moisture standard. And this goes back to like method validation. So for me, I was actually kind of shocked at how poorly these moisture balances performed. I was trying to verify them using this typical moisture content standard. And they really overestimated the amount of moisture in it. So that, I still don't know what's a good, moisture content standard for some of these instruments. I know some companies make their own moisture content standards, but some of those can be very expensive.
Right. And something like this moisture standard, it should essentially read the same for all of these different methods. But like you said, the balances are really struggling here.
Right. Yeah. So the actual moisture content of that particular standard is 15.6%, and they overestimated it considerably.
But ROS one here is pretty close, 15.4.
Yeah, that's well within the expected uncertainty.
All right, let's jump to the slide that you were thinking about. What does this slide show?
Right. Again, so here, this is the percent relative standard deviation, which is the sort of standard deviation expressed as a percent of the mean. And we can see that the reference oven and the ROS one are basically exactly where we would like them to be, between 1 and 2%. You can't really get much smaller than that. And the moisture balances, even if they were accurate, they're not very precise, which is kind of two strikes against them in my experience. So,
and this is one of my favorite questions to ask some of our clients in the food industry, is just asking them if they know the precision of their method. And most of the time they either don't know, or once they do some investigation, I think they're shocked by the numbers that they see.
Yeah, you should be able to get 2% relative standard deviation or less.
All right, from here, let's just finish with talking about choosing the right instrument for you and your team. So what instrument makes sense? There's a lot of things that you can think about. The first thing is that not all moisture analyzers are the same. We've gone over lots of different methods today. Anything you want to add to this?
Yeah, so like if you find yourself just doing like quick spot checks with like a moisture balance, do you even need moisture content? And do you need to be using a moisture balance? Could you use water activity for that metric instead?
Sure, because water activity is something that we can measure in as fast as 60 seconds now. And so you're right, if you're doing a spot check, maybe think about what you really need. The next point we have here is narrowing down your options can be really daunting. There's all these different options, all this different information. What can somebody do to narrow down those options?
Right. that's tricky. I mean, it's a case by case basis here, and so I have lots of suggestions, but I would have to sit down and talk with, I'd have to talk with you because it's like
Sure.
maybe you are having trouble getting out all of the moisture of your sample. Maybe you're burning your samples. So maybe you would like to switch. So
Mhm.
I think we can have those conversations.
Yeah, and I think that this webinar is a good starting point, and I hope it's helping you to already kind of narrow down your options and see what's out there and understand maybe what issues you may be currently struggling with and what else is out there. The next option we have here is that many instruments claim to be multi-purpose. What do you mean by this bullet point?
Well, again, so you can't just put any sample in you can't just put like a bunch of grain in a Karl Fischer titrator.
Mhm.
It's not going to work. Similarly, you're going to have issues putting certain samples in a microwave or in a moisture balance.
Mhm. And I think this really highlights how helpful the ROS1 can be because it is really sample agnostic. You can put just about any sample in there, and using that algorithm and that method that I mentioned earlier about tracking the evaporation rate is how we make sure we get the right measurement. The last one here we have is quality versus quantity. What do you mean here?
Yeah, again, I think this goes back to the metrics. Like, do you need, is this moisture content, this fast moisture content that you're getting, is it reliable? And
Mhm.
is that actually helping you with yield?
Um, Thank you guys so much for listening. Like Connor said, a lot of your products that you're measuring or things that you're working on, it does take sitting down and speaking with us and making sure that you get the right instrument. Here's our contact information. You can reach out to our sales line. Here's their email as well as their phone number. We'd love to talk with you. You know, if there's something that caught your attention in this webinar, you know, we're happy to just talk it through with you and understand your products better. I always like to push in for the Water and Food podcast. So if you're looking for something to listen to that's related to food or pharma or even cannabis, please tune in. We're also always looking for new people to come on the show. So if that's something that you're interested in, please reach out to us. So I'm going to go ahead and leave this on our contact page. And if there are any questions now, we'll go ahead and take them.
All right. Yeah. Thank you, Zachary. Thank you, Connor.
Yeah.
We'd like to use the next few minutes to take some questions. We've got several questions that have come in already. Thank you for those. There's plenty of time to submit those questions, and we'll try to get to as many as we can before we need to cut out here. If we don't get to your question, don't worry about it. We've got them recorded, and either Zachary or Connor or somebody else from our Meter Food team will be able to get back to you and respond to those questions via the email that you registered with. So with all that said, let's start with our first question here. You mentioned this in passing here and there throughout the presentation, but can you talk a little bit more about why moisture content might not be a good measurement for quality control? Maybe why water activity might be better or something along those lines?
Yeah, sure. So water activity is a really high precision, highly accurate measurement. It's something that we have standards for, and it really allows us to pinpoint and understand the water energy in your product. So if you're concerned about reaction rates, or if you're concerned about some type of physical transition like caking and clumping, or microbial growth, this really allows you to understand where your product is and then avoid these issues. And it takes a little bit more understanding of your product and maybe using an isotherm like I mentioned earlier. But I think it just really helps to pinpoint where you're at for your product. Whereas moisture content, there's always going to be lots of variance and it's harder to understand. So like Connor mentioned, moisture content's really good for yield. Anything else that you would add, Connor?
Yeah, I think that pretty much sums it up.
Mhm.
I think a lot of people are familiar with moisture content more as a concept, and so
Sure.
that becomes sort of the de facto how much water is in my sample measurement. But
Mhm.
uh, you should really consider water activity in certain scenarios.
Mhm.
Great. This next one here, I'm asking about the Karl Fischer method. They were asking about the instability of the methods and equipment that might go into the Karl Fischer method. Could you explain that a little bit more?
Yeah, so Karl Fischer titrator, basically it's water sensitive, right? So the other thing is you can't completely seal off Karl Fischer titrator. So you constantly have to keep calibrating it. Every time you take a measurement, you have to calibrate it. So it's a constant struggle to get that instrument stable because it's always drifting, right? So water is always impinging on it. It can be slow. It can be slow, but it's something that you always have to consider.
There's another one here. Someone was asking what were the brands of the moisture balances that you were using in your testing?
I think there was, I think there was an O-House one. There's a Mettler one, and I can't maybe it was either a Torbal or Veritas. One of those two. I can't remember.
Yeah, I think we just tried to pick kind of the top brands that we see people using.
Yeah.
Okay, to get some kind of representative sample there. This other question, could you explain a little bit more about the auto dry detection? And yeah, just a little bit more about that.
Yeah, so I kind of briefly mentioned this, but the way that this auto dry detection works is there's an algorithm working in the background, and basically what we can detect is that rate of evaporation. So we're drying down that sample for about 4 minutes, and right near the end of this test, it can actually determine how quickly the water is evaporating, and as that evaporation slows down, the instrument can detect this. And to make sure that it stops right at the right point, it starts taking more measurements right at the end of the test so that it can stop it right when that sample is dry. So this is what makes our instrument really unique. And this is what takes away the need to develop any type of method, is because this is already built in and it can detect that slowing of evaporation to start the test correctly. What have you seen, Connor? I know we looked at a lot of kind of problematic samples like the dried fruit and the protein powders. Did you see any type of burning or anything on the ROS one that was concerning?
No, I mean, obviously, if you crank up the temperature to, something that's absurd for your particular sample, then you can get burning. But, something we didn't mention was that you can't get the sample absolutely dry. There's no such thing as so it's only as dry as the environment. So that's kind of where that algorithm is doing a really good job in saying this is a very sort of precise measurement of this equilibrium that we've reached. So I think we've done a good job of modeling that particular stability that lets us say, okay, this is dry, this is a stable equilibrium.
All right. How does this all work for high moisture samples like juices or even just water itself?
Yeah, we didn't have any of those specific samples in this presentation, but in your research, did you look at these types of samples as well?
Yeah, I would say that these are sort of the easy samples. So yeah, that water is pretty much available, or it's not bound in any sort of weird sort of fibrous matrix or anything like that. So it's just gonna readily remove itself when you heat it up. So those are the samples that are easy to sort of get loss on drying data for.
All right.
They just might take longer. Sorry.
All right. Can you tell us more about how the ROS1 adjusts to vapor pressure? This individual has never heard of that. Is that something that's new?
Yeah, I think that's a new thing. I think we've developed it. I'm not sure if it's been rolled out yet, but I think we actually had an instrument a while ago that the idea was that it would basically mimic a vacuum oven in that the vacuum ovens, I think there's a lot of misconceptions about them, but the idea is that the vacuum reduces the vapor pressure in the chamber. We had an instrument that kind of did that. It was called the True Dry, and it used desiccant tubes to blow dry air over your sample, basically removing sort of the vapor pressure factor from the equilibrium. So we did a bunch of research and figured out that, okay, well, this actually doesn't really, it's not super helpful, this whole making this instrument so elaborate. So we took that mechanism out, but we still have all that information. But I think that's something that's going to be rolled out in the future for the ROS1.
So it's kind of like a vapor pressure correction.
Yeah.
And on top of the scale that we're using and the temperature control, this is allowing us to get that measurement.
Right. So in the case of a particularly high humidity area, we could correct for that.
All right. This next one, and we've got a couple of minutes. Well, maybe we'll do a couple more questions before we end here. This next one, what's the best way to validate a moisture method?
Well, the best way to validate a moisture method is to use a standard. So you can find standards for lots of things, moisture standards for grains. They tend to be very expensive, which is probably why we don't see lots of people using them. But they do exist for a lot of samples, and sometimes they don't exist. So you have to make your own sort of internal standards, which can be a pain, certainly. But I think to really, if you really value this moisture content data, if you really value the yield data that you're getting, it's probably worth validating your methods.
All right. Have you tested sugars or sweeteners with the ROS1?
I believe we have. I don't have that data off the top of my head. So.
All right.
But I will add that we're constantly adding kind of to our data set for ROS1. So if there's something that you're interested in and you need a proof of concept, we will either conduct that testing here at Meter, or we might even have you send samples in. So we're already doing this with a lot of clients interested in this instrument who are unsure about making the switch. And we either do the research here and then show it to them, or we collect their samples and run the test and then present it to them.
Final question here. You mentioned the Bridge software desktop application that works with ROS1. Is ROS1 also compatible with Scala?
Neither of us are Scala people, but I believe yes. I believe the answer is yes.
Yeah, I believe so. I don't know why it wouldn't be. But yeah, that desktop app does make it, using it really easy. That's what we've done now, like with the Aqualab 3 and other instruments. And like Connor mentioned, I think this is kind of going backwards. I know that a lot of those moisture balances, they were made to be standalone, and anybody who's familiar with them knows that it's kind of tricky, or I don't know. I really don't like using that type of interface.
Right.
So it's easier to use the desktop, in my opinion.
There are very few moisture balances that I've encountered that let you get the data off of them easily. Usually you just have to write it down, which is super frustrating. So if you don't know, Scala is like our data sort of handling platform. And as far as I know, the ROS1 just goes right into that.
Okay. All right. That is going to do it for us today. Thank you again, everybody, for joining us. We had a ton of questions that we didn't get to. So again, Zachary or Connor or somebody else from our Meter Food team will be able to get back to you to answer those questions. A lot of great questions. We just ran out of time. Didn't have the time to get to those. But we do hope that you enjoyed this discussion as much as we did over here. And again, if you would like more information on moisture content or water activity, or would like to talk with us further, just please consider answering the short survey that will appear after the webinar is finished. Also, look for the recording of today's presentation in your email, and stay tuned for future Meter Food webinars. Stay safe and have a great day.